Hi and welcome to another very exciting tutorial. Today we are going to build this cool weather application that lets you display the weather forecast for a city that you can search for using this search bar here at the top. And this tutorial is focused on populating a user interface like this with data that we receive from the web. And in fact, we are using the darksky API, so just visit darksky.net to get more information on that. And if you're interested to learn how to access web APIs like this and how to process JSON responses, as you can see here, then have a look at the video that is linked in the top right corner at the moment. There we're going to build a nice struct or a nice helper that looks like this. And this helps us to process the information we get from the darksky API, and you can go ahead and download that from the video description below, this helper, if you do not want to worry about what happens in the background. We're not going into detail on that in this video. Instead, we're focusing on building the user interface and connecting this information we receive with that UI. You can also go ahead and download the icons that we're using in this application from the video description below. But what you will definitely need is an API key that you can insert into the forecast request, because you can't use mine, because also I only have a limited number of API requests per day that I can use. And you can just sign up for a dev account at darksky.net/dev to get a free account, and with that you get a free API key, and this is going to look something like this. But now let's get started and opening up Xcode, and what we want to do is creating a new single view application. So I'm hitting next. I'm going to call that Swift Weather. Hit next and create that on my desktop. And make this a little bigger. And we're starting with creating the user interface, which is really, really simple because we just use a TableViewController. So with the single view application comes a standard view controller that we do not want to use. So I select that in the view controller scene, just hit backspace and remove that. And instead, in the object library in the lower right corner, I'm searching for table view or just table, and this allows me to drag a table view controller to my storyboard, and this is what we are going to use. And what we also want to do is placing that table view controller in a navigation controller so that we get the navigation bar and we can give it a title. This just looks a little bit better, and to do that you can just click on the editor menu item, embed in and navigation controller, and with that we get this navigation bar at the top. We can enter city weather here, and we have a nice title for our view controller. And what we also need to do is selecting our navigation controller here on the left and tell it that it should be the initial view controller. And this gives us this little arrow here, and this indicates that when our application starts, this view controller is launched. And if we do not set this entry point, then we just don't see anything when starting the application. And with that done, we can already configure the cells and the user interface here. We are going to start with giving this cell a reuse identifier in the attributes inspector, because we need to do that in order to work with a table view, because the cells are continuously reused by the system. And for this to work, a table view prototype cell like this needs a reuse identifier, which we can enter here. Just use an identifier that you like. I'm just using cell right here. And now what I also want to do is making my cell a little bigger, something like this, and make some adjustments to it, like changing the background color. I'm using like this dark color. You can choose, of course, whatever you like. And also I want to make it not a custom style cell, but a subtitle kind of cell, or this is going to be the cell type, which gives us a title for the cell and a subtitle, which we can see at the moment. So in my city weather scene on the left, and if you don't have this outline here, what you have to do is clicking on this icon in the lower left corner here. This brings that one up. And what I want to do here now is pop up the content view and select both the title and the subtitle with Shift key pressed to select both. And then I'm changing the color to a white color so that we can read that. And what I also want to do is selecting my table view and changing the background color of the underlying view so that this has the same color as my table view cells, just for that to look a little bit better. And the last thing we really need is our search bar. So I'm searching for a search bar in my object library, and then I'm dragging that to or between the navigation bar and my prototype cell, which gives us this nice search bar that we can use. And here I'm just changing the placeholder to a city so that the user knows what to enter here. I'm just choosing New York for now. Okay, so this is all we need for our user interface. It's pretty simple, but what we also need is a class, that a TableView subclass, TableViewController subclass that we can connect with this view controller here in our storyboard. So we do not need the view controller that was created by the single view controller template, but we need a TableViewController class. So I'm going to remove that, hit delete, move it to trash, and now I'm pressing Command N on the keyboard, creating a new Cocoa Touch class, and I just want to call that Weather TableViewController. And if you do not have a subclass of TableViewController at the moment entered here in this field, then just type in UI TableViewController, which will autocomplete the name to Weather TableViewController. Hit Next and create. And with that, we have a nice Weather TableViewController subclass that we can now associate with the view controller, the TableViewController in our storyboard. To do that, I'm selecting the City Weather view controller here, clicking on that yellow icon, and I'm opening up the Identity Inspector here on the right. And to connect this view controller now with the class that we just created, simply typing in Weather TableViewController as a custom class here in the Identity Inspector. And the last step that we need to take for this all to work is to connect our search bar with our class. So what I need to do is bring up the assistant editor, and then we want to create an outlet for this search bar. So I'm pressing Control on the keyboard, dragging to my Weather TableViewController, just calling that search bar, and make sure that we have a connection outlet, and type is UI search bar, hit connect. And this property or this outlet is now created in our Weather TableViewController class. So this was the preparation for the user interface. Now what we need is to add the Weather.swift class or the Weather.swift file to our project. So I'm dragging that to my project, and now I'm selecting copy items if needed and add to targets and hit the finish button. And what we just added is not a class, but a struct that holds a data model for weather information. It also holds a very handy function that lets us get the weather forecast for a specific location. And in the completion handler here, what we get is an array of weather objects, so we do not need to worry about how we get this information, but just how we process it. And the information that we get, an array of weather objects that each of them contains a summary of the weather condition, an icon, string, and the current temperature or the temperature for that particular day. And the last thing that we need for the preparation is to add our icons. So I'm opening up the icon folder that you can also download from the video description below. I'm dragging and dropping them to the assets folder in my project. And since this is just a tutorial, I did not provide a 2x and 3x version of the, or actually just a 2x version and not a 3x version of the icons. So we just make sure to select all of them and then drag and drop each element to 2x and not 1x. And then this should work because we're only testing this on iPhone 7 and not 7 Plus. So with that done, we are ready to write finally some code in our weather table view controller. And the first thing that we should do is thinking about how we can process what the user entered into the search bar. And therefore, we need to adopt the UI search bar delegate. And this protocol requires us, or it actually does not really require us to do that, but what we want to do is using one of the functions that are provided with this protocol, which is search button clicked. This is the function that we want to listen for, and that is going to be called when the user taps the search button in the lower right corner of the keyboard. And for our search bar to really work together with these delegate functions, what we need to do is remove that code from view.load because we do not need that. And then we can use our search bar outlet and assign the delegate, which is in our case self. And with that, we can listen for updates here when the user clicked using this delegate function, the search bar search button clicked. And in this search bar search button clicked function, we need to make sure that the keyboard is hidden, or that it hides as soon as the user tapped on the search button. So in order to do that, we use the search bar that is also provided here as an argument and use the resign first responder function, which will hide the keyboard for us. And now we can check if the user entered something into the search bar using an if-let statement using the search bar, or let's first of all create a constant for that. Let's call it location string. And to this constant, we assign the search bar and its text property. And since this is an optional, we want to unwrap it, which is done with an if-let statement. And we can directly also check if the location string is empty. And of course, we want the negative of that, so we want to check if it is not empty. And only if that is the case here, we want to make sure to update the weather for location. I just add a comment here because what we want to do now is creating a function for that purpose. And I'm going to call that function update weather for location. And this is going to get one argument, just a location, as a string. And the darksky API, if we have a look at that, receives a location as a set of coordinates with latitude and longitude. So we cannot use our city string or our location string to get the information we need, which means that we need to geocode an address or to geocode the location. And since we want to work with core location here, we need to import the core location framework, because in the core location framework, we get a CL, which stands for core location geocoder. And we can use an object of that CL geocoder class to geocode an address with an address string, and we also get a completion handler. And the address string is simply our location that we get in as a parameter here or as an argument. And the completion handler gives us an array of place marks, which I'm also going to call that. And it also gives us an error that we can use to check if everything went well with geocoding the address. So we are checking if the error is equal to nil. So if there is nothing in this error object, we can assume that everything went as planned, and then we can go ahead and check if we have a location. So again, we use an if-let statement and create a location object, and here we want to assign the place marks array, use the first object from that array, and access its location property. Again, this is optional and it's unwrapped by using the if-let construct that we are using here. And now that we have a location object, we can use our weather helper and call the static function forecast with location. And it's indeed important that this is a static function, because that means that we do not need to create an object of that type, and we can just create or use this function. And as you can see, we should pass along a call location coordinate 2D, which just means that this is a type that has a latitude and longitude, and to fulfill what we need here, we just enter our location and the coordinate property, which is a CL location coordinate 2D. And in our Weather.swift file, in this function, we're using this location parameter and access its latitude and longitude to send that to the darksky API. And now that we have that, we can add our completion handler, which is an array, or which provides us with an array of weather objects. So let's just call that results. And we want to use these results throughout our application. So it is a good idea to create a property here at the top of our class. Let's just call that forecast data and initialize it with a weather array. And in this array, we can then place our results from this completion handler and work with that throughout our table view and with the table view data source functions. So here, first of all, we need to check if we really have weather information, because it is possible that something went wrong and we did not get the results that we need. So again, let's use an if let statement here, call it weather data, the object here, and assign the results. And if that works, then we can use that and assign it to our forecast data array. Simply assign weather data here, and then we can reload our table view and trigger an update of the user interface. All of that, what happens inside our geocode address string and also in the completion handler here, happens asynchronously to what happens in the user interface. But user interface updates always need to be performed on the main thread. So what we need to do here is use the dispatch queue, use main, and perform this asynchronously to what we or to where we are at the moment. And what we want to do is use self and table view and call the reload data function. And the reload data function of a table view triggers these two functions, the number of sections and the number of rows in section, and also self for row at index path. And we can now use these data source functions to populate our user interface. And we're going to start simple, uncommenting the self for row at index path function, changing the identifier to cell, which is what we did already, or what we called our table view cell. We gave that identifier to that cell earlier here. In Interface Builder, just make sure that the identifier that you use in code now is the same as you provided in Interface Builder. And then under the definition of our cell, we can create a weather object. And let's assign our, how did we call it? Our forecast data array, and access the correct element using indexPath.row, because each element here has a row, or each element, each cell has an index path consisting of a row and a section. This would be section 0, row 0. This would be section 1, row 1. But we're dealing with these sections later. For now, let's just use our cell and populate the text label and text maybe with the weather object and the summary. And also let's make sure that we have only one section for now, just for demo purposes, and the number of rows in section is going to be equal to the forecast data and its count. So we just want to display all of the summaries that we have at the moment. We're going to make some changes to that in a second as well. So let me run that in the simulator and see if this already works. We should be able to access the darksky API by now, and we also should see the summaries if everything went well. And now we can enter a search string here. Let's use New York, hit search, and nothing happens. And I guess this is because we forgot to call our function here, update for location, which we indeed did. So we should go back to our search bar, search button, click delegate function, remove that comment here, and call update weather for location, and pass along our location string right here. And then let's run this again and see if we now get the summaries that we so desperately want. And I'm opening up the simulator, launching, and entering New York again, hit return. We can access darksky API now, and here we are. So we have our summaries. We have this empty subtitle at the moment, but this is going to change in a second. So we are in cell for row at index path now again, and we want to update that a little bit more and get a little bit more information. First of all, let's start with the detail text label and text property, and here we want to display the temperature for a particular date. And to do that, I'm using a string here, using string interpolation. And now I'm accessing the weather object and the temperature. This is a double, but we just want to display an integer value. So again, I'm using integer here, putting that in some parentheses. And with that, we convert our double and get rid of the decimals. And then I'm just adding a degrees Fahrenheit at the end. And with that, we display the temperature. And the last step is the icon. I'm using cell, its image view, and its image property, which I'm going to initialize with a UI image, which has a name, and the name is indeed the weather object and the icon property. And this works because the icon property has the same value as the images that we use. So we get strings with clear day, for example, or cloudy, or sleet, or wind, and this makes it very easy for us to choose the correct icon. So now we can run this again in the simulator, and we actually have a pretty cool weather application with that already. So let me just enter New York here again, hit search, and we get the icons, we get the temperature, we get the summary, and this works really great already. But let's make some modifications. First of all, I want that as soon as my application launches, I want to display some weather information for a demo city. And therefore, I'm calling update weather for location, the function that we wrote earlier, and I'm giving it the default value of New York so that we can directly display something. And what we also want is different sections that we can use to display the date that our forecast is for, because at the moment we need to assume that the first item is today and the second item is tomorrow, and so on, and we want to give that some dates in the section title. And fortunately, this is very simple to achieve by using some of the table view delegate and data source functions. So let's make some changes here. First of all, let's think about the way the information is displayed at the moment. We have only one section, and the number of rows is equal to the number of elements we have in our forecast data array. This is no longer the case if we want to use sections as the titles for the different dates. So what we need to do is change the number of rows in section to 1, because each section gets only one row that displays the weather information. And instead, we are changing the number of sections, which is now the forecast data and its count, because each section is one date, and each date is responsible for displaying the associated weather information. So now we have as many sections as we have forecast data elements. And the next thing we need to do is providing the sections with a title, and therefore we're using title for header in section. And here we can return a string, but what do we actually want to return? Well, a date. So we need to get a date somewhere. And what we want to do is creating a date object, and we're using the calendar and the current calendar, and using the date function by adding a component with a value to date. Looks complicated, but it actually isn't as soon as you've seen what we enter here. The component could be something like a day, hour, minute, or whatever we actually want. So we want to add days because we start with today, the next section is going to be tomorrow, and so on. If you think about that, the first section actually has the index 0, then we can just pass along the section parameter that we get here, and we will simply start with today. Then in the next section, we add the value of 1, and so we are always adding a day until there are no more days to add. And we add that to today, and we get today by just accessing the date class and creating an object from it. Now we have a date, but it is formatted in its raw. Now we have a date, but it's formatted in its raw state. So we have to create a so-called date formatter to format the date so that it looks a little nicer. So I'm initializing that with a date formatter. And then we can create a date format by simply accessing the date formatter's date format property. And this needs to be defined as a string. And this is standardized through different operating systems. And I'm just using this style here, giving me a month, a day, and a year. And you're going to see how that looks in a second. But now we still need to return something. And what we want to do is using the date formatter, and now use the string from date function. And here we simply pass along the date that we got. We can force unwrap that because this should definitely work. And let's quickly build that and see what we have to do here. We still have to add the override keyword here in front of our function, and then we should be good to go. So let's now run this again in the simulator, and then we're going to see how these sections look like. And this should be pretty nice. So here we are searching for New York by default. And now we have indeed our section headings. So we get the month as the month's name, not just a number. We get the day, comma, and the year. But as you can see, this seems to be wrong because every day it's rainy, and also every day we have 52 degrees Fahrenheit. So what do we have to change? Well, let's scroll down a little again to self-row at index path, and at the moment we are accessing the forecast data array by using index path.row. And as you can see here, we always seem to get the first day or the first row from our weather data, and that is true because we are never exceeding the first row, because now our information is associated with the section. So instead of the row, we're using index path.section, and because we have 1, 2, 3, 4, 5, 6, 7, 8 sections, we can use that here to access our array. And now we could run this again and see if we get the information we need. And here we are back in the simulator and running the app, and now we should be able to see the different conditions. And this looks pretty nice already. Here we have kind of a storm icon. You could resize the icons so that they do not touch the section headings and that all of them have the same size. But I think for the demo purposes of our app, this should do. Let's just quickly search for another city. Let's set San Francisco, search for that, and here we go. Nice weather there, perhaps. So now you have seen how you can work with the information that we got from a web API, how we can use the information that is returned as an array in a TableViewController simply by using this forecast data array. You have seen how to deal with that in the number of sections function, in the number of rows in section function, and in self-row at index path by using a weather object and accessing it using the index path and its row or section depending on what you need for your specific application. So I thank you so much for watching, and I'll see you next week.